Invisergy is trying to revolutionize the way we think about building sustainability, and we do so by allowing for windows to actually become energy generating surfaces. And so we've developed a portfolio of technologies that can help convert your windows into energy generating surfaces and thereby reduce the amount of electricity that you need to pull from the grid. Buildings consume a huge amount of the electricity in the US. Statistics show that they consume up to 70% of the electricity that's generated in the US, and it also contributes to about 19% of the operating cost for a building. So the electricity usage for a building is actually a huge problem, both in terms of our energy sustainability as well as in terms of cost of operating a building. What our company does is make transparent light redirection systems. We gather the light that's incident on the surface and come up with ways to redirect it to the edges. So our goal is to enable any transparent surface to actually be an energy generating surface. So the window works by taking the light that's incident on the surface of the window and then absorbing it with the dye layer that we place on the window. That layer then re-emits the light and directs it to the edges of the window, where it is harnessed with traditional solar cells. And from the outside of the window, it is then wired into the building just by connecting two leads to it.
Where Invisergy has innovated on that is by patterning and depositing the dye in a certain way that increases the transparency as well as the efficiency of the solar concentrator.
Invisergy's business model is built on the premise that we're very good at developing new technologies.
Because you're installing an energy generating window instead of a regular window, the entire window is now a solar panel. And so you can take those investment tax credits and those accelerated depreciations across the entire window installation. We can supply to the customer a solution that is sometimes even cheaper than that of a regular window. So based on our current calculations, upon construction of a building, once you take advantage of those tax credits, you can actually save the customer between $500,000 and $1 million just in the construction. And then the energy generation would actually save the customer over time between $10,000 and $50,000 every year. Each of our windows operates between 3 to 5% efficiency. So what that basically means is that under full illumination, we can generate between 3 to 5 watts per square foot. So what we are projecting right now is that we should be able to offset up to 5% of the building's load requirement. And so that should be able to save people in the tens of thousands of dollars. So we project between $20,000 and $50,000 per year for a typical 20-story commercial building. What we would do is we would aggregate 70 square feet worth of the windows and send that to a single microinverter, then send it to a substation on the building. That way, in case there's a failure within a given module, you can actually repair it from access panels on a given floor. And so this is how we imagine collaborating with the engineers for the building in how to design the full system. We're participating in an energy design contest, and energy and sustainability are very important, especially in a larger global context. And so we realized that windows are a great opportunity for us to actually try to make a difference. Energy generation is a problem for us, especially in the US, and also building sustainability is a problem, and we need to start helping to tackle that problem.